Okay students, so now let us go for geometrical problems on combination. This is also very important topic for your exams. Clear? Sometimes they will ask problems on this. So for that reason, let us go for geometrical problems on combination. Clear? Okay. So as you all know, geometrical problems on combination means straight lines, triangles, hexagons, parallelograms. So like this, different type of geometrical diagrams or figures are going to be come in this part. So first, let us see the straight line. That means to draw a straight line from n number of points. Clear? There are n number of points on the plane. Are you getting my point? There are n number of points on the plane. So from that n number of points, we have to draw a straight lines. So how many number of straight lines we can find? Are you getting my point? So let us look at this first one. Number of total different straight lines. Number of total different straight lines formed by n points. Formed by n points on the plane, n points on the plane, of which m are collinear, of which m are collinear. Okay students, so see here, let us consider n number of points. Are you getting my words clear? So I have n number of points like this. You may imagine stars in the sky, no problem. You may imagine the stars in the sky also. There will be n number of stars on the sky which cannot be countable. That's other thing, no problem. But now if I consider n number of points on the plane, by using this n number of points, how many straight lines I can find? For example, if I draw one straight line, I need minimum 2 points. One is initial and another one is final. Clear? So using these 2 points, I can draw one line which is straight. Clear? So that means to draw one line, I need initial point and final point, that is 2 points. So from n number, I can take 2 points. So that will be NC2. So NC2 will be the total number of the lines which I can draw by using n number of points on the plane. Clear? Because I need 2 points, initial and final, to draw a straight line. So for that reason, NC2 will be the total number of lines which I can draw from n points. Okay. But see here, which m are collinear. M are collinear means there are some points which are collinear like this. These are some points, m points. That means these are the m number of points out of n. There are n number of points. Out of this n number of points, there are some m number of points. That means m is lesser than n. M is lesser than n. There are m number of points which are collinear. That means they are on the same line. So students, see here, in this n number, all the points are included. That means this all points are included, which are collinear and which are not collinear. All those points are included in this particular term. But if these points are collinear, all these points together, they are making only one line. Are you getting my point? See, all these points together, they form one line. So what we have to do? That means out of this n, I have to remove this m. Which is making number of straight lines from this m points. That means from the M points, I can make MC2 number of lines. Are you getting my point? That means from the total number of the lines, I should remove the lines formed by this M number of points. Are you clear? That means this line will be cancelled. That means this line is also cancelled. On the same time, the lines formed by these points are also cancelled. Are you getting my point? That means lines formed by these two lines formed by these two this 2 point, this 2 point, this 2 point. For example, see here, L1, L2, L3, L4, L5, from here to here, L6, like this. All these lines will be getting cancelled in the MC2 from NC2. These number of lines are cancelled. Why? Because all these lines together we consider it as only one line, because they are collinear. If they are collinear, they are considered as one line. If all these points are collinear, they are considered as making for only one line. So this number of lines are cancelled from NC2. So now if I cancel this number of lines, in this the complete length of this line is also cancelled, but that has to be included. So for that reason it will be plus 1, NC2 minus MC2 plus 1. So this is an important formula for your straight lines. Are you clear? So from NC2 I cancel MC2, I will add 1 because NC2 gives me total number of lines formed by n points. From that I cancel the lines formed by this m points because those points are collinear. If those points are collinear, they can make only one line, because collinear definition says that the points which are on the same line, are called collinear. That means this all points together are making only one line. Are you getting my point? So what I will do, I will cancel all the lines which are made by this m points. I will cancel all the lines which are made by this m number of points, that is minus MC2. Now plus this single line, complete line has to be included. So that's why I will take plus 1. Clear? Total number of the lines from m points minus total number of the lines from the m points plus 1. Clear? If you remember that particular formula, we can solve some number of problems in this particular topic. So I think this particular point is clear to you. So now let us go for the next one. Okay students, so now let us see how many triangles can be formed from n number of points. See here, I have n number of points on the plane. From this n number of points, I have to draw a triangle. As you all know, triangle has 3 vertices. That means we need 3 points for those vertices. So to draw a triangle like this by using n number of points on the plane, so how many number of triangles you can draw like this? That means I can draw NC3 number of triangles. No problem. Total number of points are n. From that I have to choose 3. So total, if I calculate NC3, I will get total number of triangles from NC3. No problem. Clear? So now here these are the total number of the triangles which are made by n number of points. That is no problem. But let us see here. Number of total triangles formed by n number of points, from which m number of points are collinear. Again they are telling that some of the points are collinear. Clear? As we solved from the straight line for point 1. Clear? For the point 1 we have seen that NC2 minus MC2 plus 1. But here these m points are collinear. Again they are telling the same problem, that is these m points are collinear. That means again I have to subtract minus MC3. Are you clear? Minus MC3, because the triangles formed by these points has to be cancelled because they are on the same line, that is one line. With one line, these points cannot make triangle. Are you getting my point? From the one line, they cannot make a triangle because of this one line. These many points are going to be deleted because all these points are on the same line. That is only one line. With one line, as you all know, we can't make a triangle. So that line has to be cancelled. That is MC3 has to be cancelled. There we done plus 1 because that was straight line. This line has to be included. That is one line has to be included. So that's why it was plus 1. Here this line also has to be cancelled because from one line we cannot make triangle. Clear? So that is from n number of points on the plane we can make NC3 number of triangles. If m number of points are collinear, then we can make NC3 minus MC3 number of triangles from n number of points where m number of points are collinear. Clear, students? So this will be equal to, see here, this implies NC3 minus MC3. Clear, students? So this is also important point, that is how many triangles you can make from which m number of points are collinear, that is NC3 minus MC3. Okay? Okay, students. Now let us go for the third point, that is number of diagonals from n number of sides of polygon. Clear? That means there is a polygon. It may be of 3 sides, it may be of 4 sides, 5 sides, 6, 7, 8, no problem. It may be pentagon, hexagon, octagon, nonagon, no problem, decagon, anything. Clear? It must be polygon. Clear? So you can take any polygon with any number of sides, that means n number of sides. Then how many diagonals you can make? Let us see. Please remember, to draw one diagonal you need 2 vertices. For one diagonal you need 2 vertices. Let us see with some rectangle. In this rectangle we have 4 sides. To draw diagonal I need point 1 and point 2. Here again I can draw another one with again point 1 and point 2. So I can call this as D1 and I can call this as D2, diagonal 1 and diagonal 2. So here I have 4 sides for my rectangle and I can draw 2 diagonals for this rectangle. From this you can see that for each, I am telling, for each diagonal you need 2 corner points. For each diagonal you need 2 corner points, so that, see here, from n number of sides, I am choosing 2 points, or I am choosing 2 sides. Clear? From n number of sides you can take 2 corner points made by those n number of sides. So this will be the total number of the diagonals, but in this n, the all sides are included. These lines I don't need. Are you getting my point? Clear? Here what we have written, the total number of the lines, that means the total number of the lines formed by total number of the points we have written. Are you getting my point? Total number of points. Clear? From total number of points we are choosing 2 number of points. Clear? But this n is also equal to not only the points but also the sides of this rectangle. See, you have 4 corner points, you have 4 sides. Are you getting my point? For triangle you have 3 points, you have 3 sides. For pentagon, see, for pentagon 1, 2, 3, 4, 5, you have 4 sides, you have 4 sorry, you have 5 sides and you have 5 points. That means number of points is equal to number of sides of any polygon. No problem. So therefore, n number of sides you can call, or n number of points also you can call. So from that n number of points, to draw a diagonal, I need 2 points. I need 2 points. As you all know, this n of points is equal to number of sides of the polygon. This is also equal to number of sides of the polygon. This n is not only the points, corner points of any polygon. This also equal to number of sides of the polygon. Clear? So while calculating, see, if I take n number of points, from that if I choose 2, so for the diagonal I can calculate NC2, so that total number of the lines that can be made from these 4 corner points. From total number of the lines, I has to subtract this 4 lines, L1, L2, L3 and L4, because they are not diagonals. D1 and D2 are the only diagonals. Clear? So I has to cancel these 4 lines. That's why I minus with n. That's why I minus it with n. So therefore, NC2 minus n will give you the total number of sides. See, the number of diagonals from n number of sides of polygon. Please remember, in any polygon, you have how many number of points, that many number of lines are present, that many number of sides are present. Clear? So from that, I know if I take n number of points for any line, I has to take 2 points. I has to take 2 points to draw a line. From these 4 points, if I calculate total number of lines, they will be NC2. But I don't need total number of lines. I has to calculate only the diagonals. For that reason, I cancel this n side, this n sides. So that is NC2 minus n. That n can be the total number of points in the polygon or the total number of sides in the polygon. Are you clear? So while calculating or while understanding this point, you can go through that, but you just remember NC2 minus n will be the total number of the diagonals in the any polygon, because n number of points is equal to n number of diagonals in the any polygon. See, n points will be equal to n diagonals. N points will be equal to n diagonals. See, 3 triangle, 5 pentagon, 4 rectangle. Clear? So that means 5 points, 5 sides, 3 points, 3 sides, 4 points, 4 sides. Clear? So for that reason, from n points, if I choose 2 points, I can draw total number of lines. So here total number of lines 1, 2, 3, see 1, 2, 3, 4, 5, 6. Total 6 lines. But I don't need that 4 lines because they are sides. I need only diagonal. So that's why I cancel my sides so that I can get only diagonals. See here, you have 4 sides or 4 points, that is equal to 4C2 minus 4. 4C2 is 6 minus 4, that is equal to 2. So here you can draw 2 diagonals. Clear? So here you can draw 2 diagonals. For this, see, 5C2 minus 5. 5C2 minus 5. This many number of diagonals. This many number of diagonals you can draw for pentagon. Clear, students? So remember this formula, that is NC2 minus n. Clear? Okay. Okay, students. So now let us go for the 4th one, that is, if m parallel lines intersected by m number of parallel lines intersected by n number of parallel lines, then total number of parallelograms are. Okay, students. So see here, there are m number of parallel lines like this, m number of parallel lines. Clear? So to draw a parallelogram, I need 4 lines. Please remember, to draw a parallelogram, I need 4 lines. So, but first let us look at this m number of lines. That means L1, L2, L3, L4, L5, so on to Lm. Clear? So these are Lm number of lines. So on to this is Lm. No problem. So on to Lm number of lines. Clear? These are parallel to each other. Clear? To draw a parallelogram, I need 4 number of lines. I need 4 number of lines or 4 lines from anywhere. Clear? No problem. So here I have m number of lines. From this, how many I have to choose? I have to choose 2. Clear? Because see, there are another n number of lines. These are another n number of lines like this. Clear? These are n number of lines, capital L1, L2, that is L3, L4, L5, so on to Ln, so on to capital Ln. See, now some parallelograms are formed here. Some parallelograms are formed here. First, I have m number of, with small l, I have m number of lines which are horizontal. I have n parallel lines which are vertical with capital L. Clear? So, to form this parallelogram, I need 4 sides, F1, F2, F3 and F4. Among these 4 sides, horizontally I have 2, see, horizontally I have 2, vertically I have 2. That means from total m lines which are horizontal, from that I choose 2, and which are vertical, from that again I choose 2. So if I multiply this each other, because I has to choose 2 from horizontal, 2 from vertical, with fundamental theorem of multiplication, if you see, you can take MC2 multiplied with NC2, number of parallelograms can be made from m number of lines which are parallel, which intersect with n number of lines again which are parallel. Have you got my point? See, n number of horizontal lines, n number of vertical lines. From horizontal I choose 2, from vertical I choose 2. Clear? So from horizontally I choose 2, from vertically I choose 2. So therefore MC2 multiplied with NC2 gives me the total number of the parallelograms which can be formed from all these lines. So that is MC2 multiplied with NC2. Clear? Okay students, see here, now n points on the circumference of the circle then. Okay, so let us go for the 5th one, that is, here we have n points on the circumference of the circle. So let us draw a circle. On this circle I have n points, 1, 2, 3, 4, 5, 6, 7, so on to I have n. Clear? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on to n. Clear? So I have n points on the circumference of the circle. So now n points on the circumference of circle, then number of straight lines equal to how much? Again the same, NC2, as you all know. Clear? I am explaining from the first point, that is, for a line we need 2 points, from the n points we need NC2, because here no lines are going to be what is, no, sorry, no lines are going to be collinear because this is circle. Clear? Collinear means the points, the same points on the line, straight line. So the points are being on the straight line are going to be collinear points. Here no points are going to be collinear. If no points are collinear, NC2 will be the number of straight lines. Second one, number of triangles. Number of triangles equal to, again same, NC3. Number of triangles equal to NC3. Third one, number of rectangles. Number of rectangles will be equal to how much? NC4. Clear? Again, number of pentagons how much? NC5. Number of hexagons how much? NC6. Number of octagon is how much? NC7. Clear? So like that. So number of octagon is NC8, nonagon, NC9 decagon, NC10, so on, like that. Clear? For straight line, NC2. For triangle, NC3. For rectangle, NC4. For pentagon, NC5. Hexagon, NC6, so on. Clear? So like that, by choosing these n points on the circle, I can draw that many number of lines, that is NC2. Number of triangles, NC3. Number of rectangles, NC4. Number of pentagons, NC5, and so on. So this is also one of the important point. Clear? Okay students, so now let us look for some of the problems on geometry. Clear? So geometry and combination, the mixture of two concepts of geometry and combination. Okay, if polygon has 44 number of diagonals, in one polygon there are 44 number of diagonals, then how many sides it has? How many sides it has, we have to calculate. Okay, see here, I have already we know the formula, that is NC2 minus n. This is the total number of the diagonals made by a polygon. Clear? The total number of the diagonals made by the polygon is NC2 minus n, that is equal to how much? 44. So this we have to simplify. That is n factorial divided by 2 factorial into n minus 2 factorial. So if I simplify that, so n into n minus 1 divided by 2 minus n equal to 44. Clear? So if I simplify this, n square minus n minus 2n equal to 88. So it will be n square minus 3n minus 88 equal to 0. So you factorize this, you factorize means you are going to get n equal to 11 and n equal to minus 8. Clear? So n equal to 11 and n equal to minus 8 you are going to have. Therefore, the total number of the sides are, n equal to 11, because minus 8 cannot be your answer just because it is negative. Negative we can't say counting of any diagonals or any persons. Negative cannot be counting. So for that, counting numbers can be positive only. So n equal to 11 will be your answer. Therefore, 11 is your answer. You simplify this NC2 minus n in detail, no problem. I have skipped so many steps here. So you just simplify those steps and see n into n minus 1 divided by 2 minus n will be equal to 44. So if I simplify n square like this, you are going to be get n square minus 3n minus 88 equal to 0. So if I simplify or factorize that, you are going to have n equal to 11 and n equal to minus 8. So 11 will be your answer. Clear students? If you get 11 as your answer, then how many diagonals it can have? If in the polygon you have 11 number of sides, the polygon with 11 number of sides will make how many number of diagonals? 44 number of diagonals. Polygon with 11 number of sides will get 44 number of diagonals. Clear students? So 11 is your answer. Very easy. So you go on through these calculations, it will be very simple. Okay students, see the next problem, that is the number of diagonals in octagon. The number of diagonals in octagon. Octagon means 8 sides. Clear? So again 8C2 minus 8 equal to, you have to calculate, because this is the formula for the number of diagonals in a polygon with n number of sides, that is nc2 minus n, here n value is 8. 8c2 minus 8. So this will be equal to how much? 8 factorial divided by 2 factorial into 6 factorial minus 8. Cancel 6 factorial and 6 factorial. 7 into 8, cancel 2 and 2, it will be 7 into 4 minus 8. So it will be 28 minus 8, that is equal to 10. Clear? So see here, 8c2 minus 8. If I simplify 8c2 minus 8, that is 8 sides. Octagon has 8 sides. 8 factorial divided by 2 factorial. 8 minus 2 means 6 factorial. Cancel 6 factorial, 6 factorial. 7 into 8. So 7 into 8, cancel 2 with 8. That is 7 into 4 minus 8. So it will be equal to 20. That means in an octagon, you can have 20 number of diagonals. 20 number of diagonals. If you go for pentagon, what you do? For pentagon, 5c2 minus 5. For hexagon, 6c2 minus 6. For nonagon, that is 9c2 minus 9. Clear? Polynomial with 11 number of sides, 11c2 minus 11. 11c2 minus 11. Like this you have to calculate. So if they ask any number of polygons with n sides, no problem, you use this formula. Clear? So octagon 8c2 minus 8, that is 20. So 20 number of diagonals will be there in octagon. Clear? Okay students, so let us go for the third problem. That is the number of triangles that can be formed, by 5 points on the line and 3 points on the parallel line. Okay. So you have to make a triangle by 5 points on the line. See, there are 5 points on the line. 5 points on the line and 3 points on the parallel line. 3 points on the parallel line. So, by using these points, you have to calculate the total number of triangles that can be formed. Okay, no problem. Let us see here. We know the formula, that is the total number of the triangles formed by n number of points. The total number of triangles formed by n number of points is NC3. NC3. So here n value will be how much? 5 points plus 3 points, that is 8 points. So 8C3 will be the total number of triangles formed by this 8 points. Clear? But 5 points are on the same line, 3 points are on the same line. That means using these 3 points I can't make any triangle. Using these 5 points I can't make any triangle. I can make using these two and these points. That means for making me a triangle, I has to choose a point from line 1 and line 2. See, to form a triangle, I has to choose the points from line 1 and line 2. Clear? I can't choose the points of the same line. I can't choose the points of same line. Here also I can't choose the points of same line. That means I can't use these 3 points to a triangle. Only these 3 points to a triangle. I can't use these 5 points to a triangle. But I can use combining these 2 lines points. That means from this and this I can choose the points. Because these points are collinear. These points are collinear. So I can't use the collinear points to form a triangle. Clear? So non-collinear points must be used. Clear? So then, out of this 8, this 5 are also included. Out of this 8, this 3 are also included. So now what I have to remove? I have to remove the triangles made by these 5 collinear points. Are you getting my point? Triangles made by these 5 collinear points has to be removed. Triangles made by these 3 points also has to be removed. That means I have to remove triangles made by these 5 points. Minus 5C3. Clear? I have to remove these triangles. That means the triangle made by these points, that is minus 3C3. Clear? So this must be your answer. See, which one is your answer? Is it A? No. Is it B? Let us see. It is B. Let us see. It is C. This can't be your answer. This can't be your answer. What about none of these and these two? I can't cancel none of this, or I can't mark none of this. Either it must be B, either it must be D. If D must be your answer, you should delete B. Clear? Okay, again let us see it. 8C3, 5C3. So we all know that 3C3 is 1. So 8C3 minus 5C3 minus 1, because NCN is 1. Clear? So 3C3 will be 1. Therefore, your answer is B. Therefore, your answer is B. So, my dear students, make sure that before going to none of this, all the remaining has to be deleted. See, I have deleted two options, but I have not deleted these two. Clear? In these two, I went again for my calculations. I see there 3C3, it was 1. Therefore, I delete none of this. Clear? Because whenever you are going for none of these as your answer, you must be in the position that you are deleting the other options. That is what the answer. None of those. If you delete all those, that means none of that. So therefore, if you are going for none of this, you have to see your calculations one or more times. Then you come to the conclusion for none of this. Otherwise, here we had 8C3 minus 5C3 minus 3C3. Clear? So directly if I see that and if I make none of this as my answer, it was wrong, because 3C3 is nothing but 1. Clear? So 8C3 minus 5C3 minus 1 is your answer. Okay? Okay students. So now let us see the number of triangles that can be made by 12 number of vertices. 12 number of vertices. See, 12 number of vertices. You know the formula, don't make hurry. 12C3, so on, calculate and answer, because still the problem is not over. Don't make hurry. That is, read complete problem once, then understand and then solve. Don't make hurry while solving the problems. By saying 12 vertices, 12C3, if you calculate, you will get the answer. That is wrong. But because you have not read the complete problem, the number of triangle is made by 12 number of vertices in which 7 are on the same line. See, as we are calculating so many number of problems, you are getting through so many number of techniques here. Clear? As I said, the points on the same line cannot form a triangle because they are collinear points. Collinear points cannot form a triangle. So that's why non-collinear points are essential to form a triangle. So for that reason, again, if you see here, you have 12 number of points. Out of this, you can choose 3. Out of this 12, you can choose 3, so that you get total number of the triangles formed by these 12 points. But, see here, 7 are on the same line. 7 are on the same line means 7 points are collinear points. So that has to be cancelled here. That means collinear points has to be removed. The triangles formed by the collinear points has to be removed. So that 12C3 minus 7C3 will be your answer. Therefore, 12 factorial divided by 3 factorial into 9 factorial. Clear? Minus 7 factorial divided by 3 factorial into 4 factorial. Clear? Cancel 9 factorial and 9 factorial. 10 into 11 into 12 divided by 3 factorial is 6, minus 4 factorial cancelled, 5 into 6 into 7, 6 factorial, that is 3 factorial means 6. Clear? So 6 into 1, 6 into 2, 6 cancelled. Therefore 10 into 11, 22 into 10, that is 210 minus 35. Sorry, 220 minus 35. 220 minus 35 means it will be 1. 220 minus 35, that is 5. 12 minus 4, 8. So that is 185. So your answer will be 185. Clear? I think you got how I am calculating here. Clear? 12C3 means total number of the points. Using 3 you can form a triangle with the total number of points, but 7 points are collinear. That collinear points has to be removed. That means the triangles formed by these 7 collinear points has to be deleted, because you can't form a triangle from using collinear points. Because those points will be on the same line. With one line you can't form a triangle, so you have to remove that. Therefore 12C3 minus 7C3, we do the calculations, answer will be 185. Therefore answer is 185. Okay students, now let us go for the fifth problem, that is, how many triangles can be formed by using 4 points on the circle? How many triangles can be formed by using 4 points on the circle? So as you all know, the formula is NC3 for n number of points on the circle. Therefore here n is equal to 4. 4C3 will be your answer. So that is 4 factorial divided by 3 factorial. 4 minus 3 is again 1 factorial. If I cancel 3 factorial and 3 factorial, your answer will be 4. So answer is 4. Clear? That is 4 number of triangles that can be formed by using 4 points on the circle. By using 4 points on the circle. If there are 5 points on the circle, that is 5C3. If there are 5 points, it is 5C3. Again it will be 5 factorial divided by 3 factorial. 5 minus 3 is 2 factorial. Clear? Cancel 3 factorials. 4 into 5 divided by 2. So it will be 10. See, if the 5 sides, you are going to have 10 triangles. If 4 sides, you are going to have, if 4 points, you are going to have 4 triangles. If 5 points on the circle, you are going to have 10 triangles on the circle, so on. 6 points on the triangle, that means 6C3. 7 points on the circle, 7C3. 8 points on the circle, 8C3. That many number of triangles you can make. Suppose if they ask lines for the same problem, in the place of circle, if they ask line, see, if they make this as line, what you will do? 4C2. Clear? You have to calculate 4C2. It will be 4 factorial divided by 2 factorial into 2 factorial. Therefore, 2 factorial cancelled. 3 into 4 divided by 2. 2 into 1, 2 into 2. Therefore, 6 lines. Clear? You can form 6 lines by using 4 points on the circle. Suppose if there are 5C2. Clear? 5C2 means what? 5 factorial divided by 2 factorial into 3 factorial. 4 into 5 divided by 2. 2 into 2. So 5 into 2 is 10. Clear? So that is 5C2. That means 10 lines you can make. Clear? 3 factorial cancel. 4 into 5, 2 into 2. Okay. So 5 into 2. 10 lines you can form if you have 5 points on the circle. If you have 4 points on the circle, again you can make 6 lines. If you have 4 points, you can make 4 triangles. If you have 5 points on the circle, you can make again 10 triangles. Clear? Again here 3 factorial cancelled. That is same. Clear students? So see here, these two are same. That means 5C3, 5C2 are same. Same number of triangles, same number of lines. If you go on doing this many number of problems, you will go with so many number of results, new results. See, number of triangles are also same, number of lines are also same. They can ask, clear, if 5 points are present on the circle, then number of circles are 10, number of triangles, if there are 5 points on the circle, see one problem, that is, if 5 points on the circle, then 10 number of triangles, 5 number of lines, option A is 10 circles, option B 5 lines, option C triangles equal to lines, option D none of this. This also they can ask. Clear? So you must be in the position of answering that particular problem. See here, 5C3, 5C2 both are same. That means number of triangles will be equal to number of lines if the circle contains 5 points on its circumference. So like this, whenever you are solving more number of problems, you are going to have with more number of results like this. So like this you have to study, no problem. Okay, I think this particular problem is clear. Okay, if there are 4 points on the circle, then how many lines can be formed if 4 points on the circle? How many triangles can be formed, how many lines can be formed by the 4 points on the circle? That was how much? 6. Clear? In one problem we created 3 problems. First the problem was how many triangles can be formed. First our problem was how many triangles can be formed by using 4 points on the circle. So by using that we have solved. The answer is 4. Next, for the same, again we have calculated that how many number of lines. For the same, we calculated how many number of lines can be formed by 4 points on the circle. Then we went for, that is, if 5 points on the circle, then how many number of, number of triangles is equal to number of lines. Clear? Number of triangles is equal to number of lines. So we have solved 3 problems on the same problem. Clear? Okay students. So now let us go for the next problem. That is, see here, the number of straight lines that can be formed, by 20 points. That means you have 20 points, no 3 of which are in the same straight line. See, in these 20 there are no points, no 3 points. That means there are no more than 2 points which are on the same line. That means, see, 20 points, no 3 points of which are in the same straight line. That means no 3 means no points are on the same line. That means no 3 points are on the same lines. Among these 20, any points, that means no 3 points, any of these 20 may be 3. That means there are total 20 points. Out of these 20, no points are on the same line. That they are telling here. That means they are confusing with some English grammar. Don't get confused here. That means 20 points, no 3 of which are in the same line. That means out of this 20, no points are on the same line, straight line, except 4. That means out of this 20, 4 points are on the same line. I think you got the problem. Clear? You have to understand the problem carefully. See here, the number of straight lines that can be formed by 20 points. That means from this 20 you have to form the straight lines. Clear? No 3 of which are in the same straight line. That means out of this 20, no points are on the same line except 4. That means 4 points are on the same line out of this 20. That means these 4 points are collinear. collinear. Clear? So therefore, how many number of straight lines you can form? I think you understood the problem. Clear? You have to understand the problem line by line. Otherwise, solution will be very simple. But you have to understand the problem. Sometimes they will confuse you in the problem. Clear? So, you all know the formula for forming the number of straight lines from n number of points where m number of points are collinear. I have already discussed that formula. The formula was what? NC2 minus MC2 plus 1. This was the formula. For number of lines can be made from n points where m number of points are collinear. Clear? So, this is the formula. Therefore, 20C2 minus 4C2 plus 1 will be the answer. So 20C2 means what? 20 factorial divided by 2 factorial into 18 factorial. 18 factorial, 18 factorial cancelled. 19 into 20 divided by 2 minus 4 factorial, 2 factorial, 2 factorial cancelled. 3 into 4 divided by 2 plus 1. So 2 into 1, 2 into 10, 190. 2 into 2, 3 into 2, 6. 190 minus 6. 190 minus 6 is 186. 190 minus 6 is 186. 190 minus 6 plus 1. So this is 184 plus 1, 185. So answer will be 185. Clear? So therefore answer is 185. Very simple problem. You have 20 problems, out of which are 4 points are collinear. If they give direct, it was very simple, but they are twisting the problem. In the indirect form they are telling. What is indirect form here? See, 20 points can be formed from 20 points. This is full point. No 3 of which are in the same straight line. This is the confusing line. Clear? No 3 points are on the same line means out of this 20, no points are on the same line except this 4. Except this 4. That means 4 points are collinear out of this 20. Like this, they are going to confuse you in your exam. That you have to be careful. Clear? So 20C2 minus 4C2 plus 1. That will be equal to 185. Therefore, answer is 185. Okay, students. So now let us go for the next problem. That is the number of diagonals of a polygon of m sides. The number of diagonals of a polygon of m sides. That means polygon contain m sides. Then what are the total number of the diagonals they are asking? They have given 4 options, no problem. Clear? So that is, see here, MC2 minus m will be the total number of the diagonals of the polygon. But this we have to simplify. M factorial 2 factorial into m minus 2 factorial minus m. Clear? So here if I cancel m minus 2 factorial, it will be m into m minus 1 divided by 2 factorial minus m. Clear? So if I simplify here, see this, it will be 2 factorial means 2, 2 into 2 will be 2m. If I simplify here, minus m will be m into m minus 3 divided by 2 factorial. M into m minus 3 divided by 2 factorial, because LCM is 2, 2 into m will be minus 2m, minus 2m, minus m will be minus 3m. So if m is common, m into m minus 3 divided by 2 factorial will be your answer. Clear? So MC2 minus m is nothing but m into m minus 3 divided by 2 factorial. That is your answer. Clear? It was very simple problem. No worries. Okay, students. So now let us go for the next problem. That is let Tn denote the number of triangles. Let Tn denote the number of triangles which can be formed by using the vertices of regular polygon of n sides. Full point. If Tn plus 1 minus Tn equal to 21. Clear? Okay. Then what is n they are asking? That means what is value of n they are asking of regular polygon of n sides. Clear? Okay. So understand the problem. Tn is the number of triangles. Tn equal to number of triangles from n vertices of polygon. If this statement Tn plus 1 minus Tn equal to 21, what is value of n they are asking? Okay. Tn equal to number of triangles from n sides means this is nothing but NC3, because we know the formula for triangles formed by n number of points on the plane, that is NC3. Clear? So Tn equal to what? NC3. See, Tn is NC3. What is Tn plus 1? Here Tn is NC3. What is Tn plus 1? It is n plus 1 C3. n plus 1 C3 minus NC3 equal to 21. I think you got my terms. See, Tn denotes the total number of triangles formed by n number of vertices of polygon. Clear? That is what they are given. Clear? Tn denotes the total number of triangles formed by n number of vertices of polygon. That means Tn is the total number of triangles. Tn is the total number of triangles. Formula is what? As we all know, formula is NC3. Formula for the triangles formed by n points is what? NC3. So NC3 will be the total number of the triangles formed. Therefore, Tn equal to NC3. Then what is Tn plus 1? That means this will be what? Triangles formed by n plus 1 number of vertices. Triangles formed by n plus 1 number of vertices. So it will be written as n plus 1 C3. Clear? n plus 1 C3 minus NC3 equal to 21. The problem is very simple, but you must know some formulas. Clear? You must know the formula of the triangles formed by n number of points. That is first formula you must know. Next, see here, n plus 1 C3 can be written as NC3 plus NC2. This also you must know. n plus 1 C3 can be written as NC3 plus NC2. This is from the results of combination. These all results are in your 12th standard NCERT textbook. Clear? So minus NC3 equal to 21. So now it looks very simple. NC3 cancelled. NC2 equal to 21. See, NC2 equal to 21. Now you simplify. NC2 equal to 21. That is n factorial divided by 2 factorial into n minus 2 factorial equal to 21. Cancel n minus 2 factorial, n minus 2 factorial. It will be n into n minus 1 equal to 42. Clear? So here you get algebraic equation, that is n square minus n minus 42 equal to 0. Therefore, n equal to 7 and n equal to minus 6 you are going to have if you simplify this. So therefore, n equal to 7 will be your answer. N equal to 7 will be the answer. Clear, students? So problem is very simple, but you must know the formulas and you must know the techniques of solving that particular problem. Clear? Okay, so therefore answer is n equal to 7. Now let us go for the next problem. Okay, see, the problem is the number of parallelograms that can be made of 4 parallel lines intersecting on other set of 3 parallel lines. That means there are 4 set of parallel lines, another 3 set of parallel lines which are intersecting to each other. We can draw it diagrammatically, that is 1, 2, 3 and 4 parallel lines. There are another how many? 3 number of parallel lines intersecting each other. So this is 1, this is 2 and this is 3. So these 3 parallel lines are intersecting to each other. Therefore, see how many parallelograms are formed. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5, 6. 6 number of parallelograms are formed. So diagrammatically we are looking at 6 parallelograms. Clear? So if we simplify, let us see, that is 4C2. From horizontal we are choosing 2, from vertical we are choosing 2. Clear? This type of problem already we have solved once. Clear? From m number of parallel lines which are horizontal, n number of vertical lines which are parallel to each other. Therefore, if they intersect each other, mc2 into nc2 was our formula. By using that, 4c2 into 3c2. Already we have discussed this formula with n number of horizontal lines, m number of vertical lines. If they intersect each other, the formula is nc2 multiplied with mc2. So therefore, here 4c2 multiplied with 3c2. 2 factorial will be cancelled. So 3 into 4 divided by 2. This will be cancelled here. 3 into 2, 6. So 3 factorial divided by 1, 2, 3. 3 into 2 means 2 factorial, 1 factorial, 2 cancelled. Okay, see here. 3 into 2, 6. 6 into 3, 18 parallelograms are formed. 18 parallelograms are formed. That means in this there are 18 parallelograms. Diagrammatically we are looking at only 6, but still there are 18 in this. Clear? So you take this diagram on your white paper and you calculate total parallelograms on this. For example, 1, 2, 3, 4, 5, 6. This is 6 parallelograms. This is 7. This is 8, this is 9, clear, complete, this is 10. Like this you go on simplifying. Therefore, you are going to have total 18 number of parallelograms. Clear? 6 boxes, 6 parallelogram, complete box, 7th parallelogram. This one, 10 parallelograms. Again you go on calculating like this. That 2, therefore 12, so you go on calculating 14, like that you will get total 18 number of parallelograms in this diagram. But diagrammatically it will take a time to calculate all 18 parallelograms. But when you look at this formula, it will be very simple, that is 4c2 multiplied with 3c2, where we were using the formula. Therefore 4c2 is 6, 3c2 is 3. Therefore 6 into 3, it will be 18 number of parallelograms which can be formed by 4 number of parallel lines intersecting with 3 number of parallel lines. Clear? So therefore 18 is your answer. You take this on your white sheet and you calculate. In this you are going to get 18 number of parallelograms. Clear?